Hello, I'm Eric Snodgrass, and thank you for watching this weekly Ag Weather Update brought to you by the Farm Credit Associations of North Carolina. First of all, Happy New Year, everybody. And as we get into this new year, some of the big questions that I'm going to continue to be asking are, what is this map going to look like as we progress through the rest of winter into spring and summer? And also, what do we expect the outcome of this fading La Nina to be? So those are going to be two big questions we're going to try to answer a lot over the next couple of months. But as it stands right now, we look across the country, there's still about 70% of the land area that is in some form of drought. Okay, that goes from abnormally dry all the way up to D4, which is exceptional drought. The greatest drought is anchored in the central plains of the United States in terms of the depth and longevity of the drought. And then in the western part of the United States, although there's been a lot of recent precipitation in the west that we have to take a quick look at here. Now, in the Carolinas, we have seen over the last month to 45 days that if there's a place that's been a bit drier, it's been closer to the East Coast. So it's been in the southeast and along the coastal regions here. But we have questions as to whether or not that drought will be remedied by this upcoming pattern. I do have some positive news in that regard, because we do not want to start spring with deficits in soil moisture. That is just a recipe for early and often drought reoccurrence in the summer. Okay, so I would like to show you this. This is what it looks like when you look back on the drought monitor page to the inception of the modern drought, the modern drought monitor, which began in the year 2000, and shows you the percent of land area under different forms of drought. And so you can see the category down here, D0 to D4, all the way up to D4. And when we look back at this, we try to correlate, like, what drove the drought we saw in like 2001 into 2002. What about again in 2007, 8, and a little bit into 9? What about 11 and 12? And then, of course, in late 16, 17. And almost always, it has to do with the rebuilding and kind of the permanence of a large ridge over the East Coast. That also drives quite a bit of heat, but it just blocks tropical systems in summer. It blocks the moisture return for thunderstorms in summer, and in spring it can just shut us down in terms of getting good Gulf moisture or Atlantic moisture over us. So that's the big picture here. Big blocking ridges is what we got to be on the lookout for. But what I want to do here is I'd kind of like to assess where we currently stand and if we have risk of that going forward in this winter. So here we go. This is the last 30 days of precipitation, expressed as a percent of normal. And again, we've had very, very heavy rain and snow in California and Nevada. Pacific Northwest is shaping up to have a good start to their winter season. The Northern Plains, very, very snowy. In fact, there's a winter storm warning out for this region running through here again today. It's really primarily been the Western Plains getting down into Texas, Western Texas and New Mexico. That's been very, very dry. Some of the issues in the Eastern Corn Belt with drier conditions from this fall have recovered, and even though there's still a few drier pockets in through here, we've made a pretty quick recovery in this part of the country with respect to moisture. And the Mississippi River has recovered enough to have barge traffic going up and down it again. In the southeast, talk about Georgia and Florida, and then right here along the coastal areas that have been a bit drier as of late. So this kind of just gives us a picture of where we've been as of late. So I want to talk about January and February, the month we're in, of course, next month. And I went back and used one of my favorite websites from NOAA and reconstructed the combined January-February total precipitation from 1895 all the way to present. And what I wanted to do here is I really wanted to figure out what caused the highly anomalous setup. So what made things quite dry and what made things really, really wet. And I was mostly concerned about the wet side of this, okay? So what I did was I took the 10 or 11 wettest years since 1970, just looking at the most modern era, and I want to understand what drove those really wet years. So this is what you have to be on the lookout for. If we continue to see deep troughs of low pressure coming around, like Western North America, specifically British Columbia into the Pacific Northwest, and those troughs come diving into the southern plains. And at the same time, there's a blocking ridge, usually somewhere between like Ontario and Quebec near the Hudson Bay. The flow ends up doing something like this, okay? And you end up getting a complementary trough that's just off the coast, completing what we call an omega pattern. You can see how that looks like the Greek letter omega. If the atmosphere prefers to go into this configuration in January and February, we get a lot of Gulf Coast storms, we get a lot of Miller B storms that come in like this, and they have to make a very quick turn. High pressure right here, this is important, high pressure right here is what can drive some of the most active winter cyclones, winter extratropical cyclones coming up the East Coast. Those are the big nor'easters. These are the ones that can really bring in a lot of precip. So this is a pattern that we want to be on the lookout for if things are going to go wet. So stuff this in the back of your brain for just a moment. Because what I did next was I said, well, what's it take to get really cold? So across North Carolina, these are the January and February averages going back to 1895. All right. And as you look at this, we see, wow, there's a really cold stretch here in the late 70s. We've had other quite cold punctuating years here, but I pulled off again from 1970 to present some of the coldest years, and this is what we got. So when you put it all together, what we need to see if we're going to have really, really cold conditions is that big blocking ridge needs to slide just a bit further over toward Greenland. All right. And what that allows to happen is the big trough that was here to slide east with it. And so what you end up getting here are deeper troughs of low pressure that are now anchored right here over the mid-Atlantic. And that's what delivers the really, really cold air. So the flow has to come out and around like this and then dive through the Canadian prairie. And then an omega pattern, I know it's off the screen, it shifts a bit farther to the east. Somewhere in between are our snowiest situations. Okay, but this is the one that delivers the cold. But you notice that we've got to have some sort of blocking high pressure feature here. And if we're going to be wet, we can't have just persistent ridging across the west. We've got to have good flow. The flow has to be open and moving. And what I want to show you is right now, that's what we're seeing. Okay, so in this forecast, as I make my way toward the end of this video, we're going to be talking about what we're expecting to see come the rest of January into February. And I think if we can continue to keep the jet stream pattern just screaming from the Himalayas, across China and Japan, across the open Pacific Ocean, uninhibited, I should say, by any sort of split or block or anything, it's going to plow on across the United States and give us better chances of seeing just more frequent winter systems. And we need those. This is the time of year to rebuild soil moisture and start to eliminate the effect of drought. So I went out there as far as I could with the operational models. If you could see me sitting here, I got my hands all the way out to my sides like, this is what we did. But what I wanted to see here is if that Pacific jet stays extended, is there any hint of a big block, for example, somewhere here or even over Greenland? And we don't see it. So while we do not expect this pattern to go cold, we got to have a big block here to go cold, I think it's going to stay wet because the flow is coming so fast across the Pacific. And then we've got this feature right here, which is at the base of some sort of trough, and it's trying to build up into the Atlantic. Now, that's part of the pattern I showed you earlier. So it's not our wettest look, but it's not a dry look either. Does that kind of make sense? We're going to see better jet stream level flow over the southeast. And what's good about this comes back to the first thing I said. For the next 10 to 15 days, the models, there's nothing right now that I can see that would suggest we build a big ridge over the southeast. And it's the ridges that shut it all down. So because of that, the next 15 days in terms of precipitation anomalies reflect that systems are going to plow into the west, very wet in California. This is great news. They're already at 70% of the snowpack for the entire year. Okay, we've got some places here that are expecting to get over 1.5 feet of liquid equivalent, so both rain and snow coming through. This is going to eat away at the drought issues here. When that occurs, systems then eject in the central United States, like the one we got now in Colorado, and they go to Maine. And as they do that, they drag fronts through us. And even though you see that for this whole region, part of the mid-Atlantic down to the southeast shows drier conditions over the next 15 days, it is not going to be dry. And I think beyond this, when that strong bit of flow in the jet stream sets up right over the southeast, we're actually going to see wetter conditions showing up in the forecast. So that's kind of the backdrop for where I want to take this particular video. Right now, we've got to deal with a big winter storm coming off of the Colorado Rockies. Now, it's going to get to us soon. Okay, we've got some wind issues here right along the spine of the Appalachian Mountains. But you can already see flood watches have been set up pretty far to our west over the Mississippi River. So there's plenty of moisture in this system. We had some pretty dense fog ahead of this one. There's actually quite a bit of dense fog still stretching throughout the midsection of the country and along the Gulf Coast. But this system, as it moves over toward us, is going to bring a thunderstorm threat. So today, that thunderstorm threat is over parts of the Mid-South and the South. So it's still west of the Mississippi River. Tomorrow, it moves into Mississippi, Alabama. And then as we get into Wednesday, that's when we have the front coming through us, the chance for some scattered storms here on the 4th. Right now, it's just a marginal risk. Appears that the system's going to kind of lose some of its upper upper level support, keeping that front away from being a more strongly forced setup, which could deliver bigger storms. But because we are going to be seeing that, let's go to the high-res NAM model and see when it gets here. You're going to notice in the beginning there is some higher pressure in place. So you can kind of see that the high is right in through here. We do get some scattered clouds and, of course, some scattered rain out of this. And here comes the front over the Mississippi River. This is late tonight and tomorrow morning. And then this spreads toward us, increasing our chances for showers late in the day on Tuesday, and then they really start to pick up on Wednesday. So this only goes out to Wednesday midday. That's when the front is just getting to the Appalachian Mountains and starts to press over the top. So we've got a lot of midweek threat for rain and possibly some thunderstorms out of this. There's quite a bit of snow on the backside of this, so maybe you're vacationing here. Yeah, there's going to be some places picking up over a foot of snow that stretch right into this area. Notice at the end of this too, more systems lined up to hit California. In fact, I think there are 4 systems lined up to hit California in the next 10 days. So let's go look at this now for when that system gets to us. We just got to switch over to a longer range model. We're going to look at the ECMWF. So we play this forward. We've already seen to this point. There's morning on Wednesday versus Wednesday midday and Wednesday evening. So you can see the models bring in those scattered storms at that point. Still very mild conditions into this area compared to normal. So that's why we're not expecting any snow. So that front clears through by the time we get into Thursday morning. And then as we work our way later into the week, on Friday, really Thursday night to Friday morning, I wouldn't be surprised if there's a little bit of light snow accumulating here in the Appalachian Mountains. That's system number 1. As we then work our way through the weekend, the European model is attempting to produce a system right here over kind of the Boot Heel of Missouri that could follow the Ohio River Valley and end up kind of right over the Appalachian Mountains. And you notice that as it comes through, there's a chance, I'm rocking back and forth over midday Saturday through midday Sunday. There's a chance for some more scattered showers and possibly a thunderstorm, although it looks to be too stable to bring thunderstorms in at this point. As we then go into next week, this is next Monday and Tuesday, we're going to watch out for possibly a storm system coming out of the Gulf next Tuesday. Whether or not it makes its way up the East Coast is all dependent on how quickly that jet stream level wind can reemerge here to deliver that. But you notice here's a next system coming into California, meaning this pattern's not really slowing down. So let's kind of stitch this all together. I'm just going to go to the European model to kind of get precipitation totals here. So we know that we're expecting the scattered rain to get to us at some point late Tuesday night, early Wednesday morning. As we play this out through the first band of rain coming through, you can see here that most of these precipitation amounts are relatively light, most of them under a ½ inch, although some of the thunderstorms could be capable of producing more. That's just the nature of a thunderstorm. So that moves on through. We then have the chance over the weekend. You kind of see it right there, just a little bit more being added Saturday into Sunday. But overall, you play this through the next 7 days, most of the state sees less than 3/4 of an inch of total precipitation. But as we said, it's what the pattern is doing. Where is it going toward? And you get out there to day 10, and you start to see a couple of those pieces. Now, do you see it? There's not a massive ridge here, but there's higher than normal heights. And a trough sneaks in below it. And troughs over us, we know, bring in the faster jet stream flow. They bring in the better chances of seeing low pressure systems develop. And that's why toward the middle of the month, we could start to see a bit more activity showing up along the East Coast. And the model's beginning to reflect that. And that's why I think as we progress through this pattern, we will see routine chances of precipitation. But as we move toward the middle of the month, those chances could start to increase. That's really what the models are suggesting at this point. By the way, this has been reflected in the newest update from the CPC. This is their January 9th through the 15th update. They've now got better chances of us seeing above normal precipitation during that time period. So we're kind of modifying a bit here what the models were suggesting. Now, on the temperature side of this, before I go long range, I just want to show you how cold it was leading up to Christmas. We did see across the state of North Carolina that our temperature anomalies were about 15 degrees colder than normal. Take a look here, though. Parts of, by the way, this is over a 7-day time period. We averaged 15 degrees below normal. There were several days in there that it was brutally cold. But in the northern plains, some places here for a 7-day time period, we're approaching 30 degrees Fahrenheit colder than normal. Well, that's all gone. The pattern is flattened out. We've gotten rid of the big high amplitude blocks. And so here's today's high temperatures on Monday, 63, Tuesday, 67 in Raleigh. Look at the heat that's coming to the eastern Corn Belt. This, by the way, is almost 30 degrees warmer than normal for a lot of these places. You'll notice as I play through on Wednesday, and then when the front clears on Thursday, the temperatures start to back off. But we don't see any really deep extended cold. We're just in the cold sector of this system as it comes through on Friday, but still highs in the mid 40s to low 50s. As we then work into the weekend, there's Saturday and Sunday, no significant drops in temperature. And as long as the Pacific jet stream stays extended like this, there's no reason for there to be high amplitude ridges to drive the cold air in. So given that, this is what the temperature pattern looks like all the way out through the next 15 days. It's a 5-day sliding window. And what you notice is we'll see some cooler air as we approach, as we approach the middle of the month. There'll be some cooler air at times, but no Arctic air. There's just no source for it. It's all located on the other side of the planet. For the next 10 days, looking at global temperature anomalies, it's not here. It's not in Europe. Very, very hot in Europe. In fact, they're in the middle of a winter heat wave here. Many people are very happy for this given the energy situation. But into Russia and Siberia, that's where the coldest air is located. Now, I'll be honest with you, I am watching for later on this month, about 10 days from now, for the potential of a polar vortex disruption. Now, I can say that till I'm blue in the face, but what has to happen for a polar vortex disruption to drop Arctic air over us is it needs to be linked up with a tropospheric trough. You can have polar vortex disruptions that do nothing. They can be disrupted and weak and loose and not have an impact on North America. There has to be a linking between what happens in the stratosphere and the troposphere. I'm keeping an eye on that for us. But just given this, let's go out there and look a little bit longer term. Now, the big story, I told you there's two parts to this. Drought was the first part, La Nina is the second. We are starting to see the La Nina begin its fade. It's going to start here first. It'll be last in the middle of the Pacific. And right now, even though we still see some decent trade winds and some decent westerly wind bursts, this is not the same magnitude of what we've seen for the last several months. And we are starting to see the MJO progress and move. There are some indications that while it is now in phase 6, it could start to move over toward phase 8 with time. And what's interesting about phase 8 is that should it make it there later in the month, that strong flow that comes in like this could be forced to go over some weak ridging in the west. And that drops in troughs over us. Now, what did we learn earlier? This could be a signal for not only a wetter, but also a bit more of an active pattern. Now, it's not the full omega block that delivers the incredibly wet conditions, but this is one way by which you can get more active conditions, wetter conditions. So to show you how the models are being consistent with that, this is kind of just a 46-day outlook from the latest European model all the way through mid-February. And you can see how the fact that trough is diving in here, we're seeing better chances of wetter conditions showing up across the East Coast. So I think we're going to have an active mid-January through mid-February given this setup. Now, that same forecast is being echoed by the Climate Prediction Center. Let's zoom in here. This is their forecast for, let's go back. There we go. This is their forecast for January. You see how they're seeing this active storm track in through this area? I just say that the models are echoing their analysis as well. So to come back to my first question, if this verifies, and this is what we end up seeing throughout the month of January and likely into February, it makes sense then that the U.S. seasonal drought outlook has also made an adjustment. All that activity coming into the West, drought improvement over us. Where it stays anchored is in the plains. Just kind of complete that story there for us. Now, beyond that, let's go take a look at maybe the bigger drivers going forward. As we talked about last year, at the end of last year, we think that the La Nina is going to start its fade in the month of January. And possibly by late winter, neutral, by spring into summer, we could be knocking on the door of having El Nino-like behavior in the flow. Now, I'm going to tell you something. I started you off with this graph for a reason. The correlations between El Nino and La Nina and our weather in the Carolinas and surrounding states are not as strong as they are for the Midwest or for the Western United States. So we can't look at this and go, oh man, there's going to be, an El Nino, that means X. But the only strong correlation I can tell you is that if we do get into late summer, early fall with an El Nino signal, historically that reduces the risk of hurricanes. But you all know that it only takes one hurricane. It doesn't take a whole season of them. One of them can do that. So that's going to be one of the main stories we're going to continue to cover. But as it stands, I want to just show you kind of an interesting graphic. I want you just to kind of blur your eyes and look at this. What we're going to do is we're going to look out from now through March, and we're just going to try to get our eyes wrapped around what we expect in terms of accumulated precipitation anomalies. Now, the blues are wetter than normal. The reds, the warmer colors, are drier. And what we see is that if I just go from now all the way out to the 5th, you see it right in through here, right? We can go out even further, all the way to March. There's just this likelihood of better flow coming into the East Coast. And that's why I think the models are more aggressive on eliminating drought, any leftover lingering drought that we may have, and really pushing the soil moisture up higher. Now, speaking of soil moisture issues, I want to take you down to South America. This is the 3 states of Buenos Aires, Cordoba, and Santa Fe. And still, through the end of December, they are showing the lowest NDVI values on record. Now remember, you can have low NDVI values because of late plant. That's where the satellite's seeing the bare ground, not new vegetation. And that's part of what's going on here. But this is also showing some stressed crops. You can see that the latest root zone soil moisture map, again, this was at the end of December, but it shows a lot of regional areas in through here that have been quite dry. Only around Buenos Aires has there been some wetter conditions. Now, we don't tend to trust these maps farther to the north into the Amazon, so we're really looking down here into Argentina. Over the next 15 days, the models continue to stay aggressive with drier conditions in central and northern Argentina, Uruguay, and Rio Grande do Sul, where there's been problems. They're harvesting soybeans already in Mato Grosso and other northern growing areas. It's very wet in the east. This is going to push for a huge soybean crop. But again, central and northern Argentina, quite dry as we continue to look forward at this forecast. Now, when will this change? One of the lead indicators of that change will come from a shift in something called the AAO, the Antarctic Oscillation. In a nutshell, when it's positive, Argentina sees fewer cyclones, fewer, not hurricanes, but I'm talking about extratropical cyclones, low pressure centers that drive fronts through the area to deliver the rainfall. So when it's positive, it's hard to get those to happen. They're farther to the south. So when this starts to go negative is when things will start to shift around. And if La Nina lets go, the AAO can come down. That's just something that typically happens. If La Nina lets go, though, what I'll be starting to get concerned about is, does this area here of weaker monsoonal flow begin to encroach more into Mato Grosso or Goiás and Tocantins, or over here into Minas Gerais or Bahia? If it does, this could impact this safrinha corn crop. As it stands through mid-February, we're quite wet in central Brazil. And even though you see drier Mato Grosso, there's still going to be, over this time period, 4 inches of rain. Just the normal is like 4.5 or 5. Notice, too, that down into Argentina, the longer-range model forecasts have lost, it's no longer in there, the risk of continued dry conditions. So we're going to have to watch this flip that could possibly be happening in the southern hemisphere while we watch our jet stream behavior change in the northern hemisphere. I appreciate the extra time you gave me today. Hope you have a good start to the new year. I look forward to getting back on our normal cadence of these videos. Thanks.